Hey guys, so today we're going to learn the third and final method of solving systems of equations. It's called elimination. Okay, elimination is my favorite of the three methods, and hopefully you guys will like it too. Okay, so we're going to solve equations by elimination, and then we're going to also look at some word problems. Okay, so 4-3 is solving systems of equations by elimination. So here's our first example. X plus y equals 7, 2x minus y equals 2. Now, the point of elimination is we are going to eliminate one of the variables. Okay, so we always look to see if we can get a variable to cancel out. So I'm looking right here at the y's. Notice that one is positive, the other one's negative. So what we can do is we can add these equations straight up and down to get a new equation that's easier to solve. Important thing is you need to match like terms. Okay, so you need to line all the x's up, line all the y's up, and then line up the constants. Okay, so my eyes are right here drawn to the y's, those will cancel. So let's add straight up and down. So I have x plus 2x gives me 3x. Y plus a negative y cancels. Equals 7 plus 2 is 9. I'm now able to solve that equation. Divide both sides by 3. X equals 3. Okay, we gotta solve for y now because remember we always need an ordered pair. So it doesn't matter which equation. I think the top one's easier. So x plus y equals 7. Instead of writing x, I'm gonna write 3. Subtract 3 from both sides. Y equals 4. So my final answer is the ordered pair 3, 4. And that's elimination. Hey, let's have you try a problem. Please pause the video and try letter A. Okay, letter A. Oh, my eyes are immediately drawn to the y's. Negative 4 and a positive 4 cancel. So let's add straight up and down. 2x minus x gives me just plain old x. Negative 4y plus 4y cancels. Equals 2 plus 3 is 5. Okay, now I gotta solve for y. So it doesn't matter which one you choose. My eyes are drawn to the bottom one, but again, it doesn't matter. So negative x plus 4y equals 3. So I'm replacing the x with a 5, so negative 5 plus 4y equals 3. Add 5 to both sides. 4y equals 8. Divide by 4. Y equals 2. My solution is the ordered pair 5, 2. Okay, pause the video and try letter B, please. Okay, so on letter B, a little bit different this time. Notice the x's are going to be what cancels, okay? 2 minus 2. So let's add straight up and down. Those cancel. 3y plus 2y gives me 5y. 1 plus negative 6 is a negative 5. Divide both sides by 5. Y equals negative 1. Okay, now I got to solve for x. Again, it doesn't matter which equation you choose. Let's pick the top one. 2x plus 3y equals 1. But instead of writing y, I'm going to plug in negative 1. 2x minus 3. Oops, I wrote 1. It should have been a 1. I wrote 3. Okay, equals 1. Add the 3. 2x equals 4. Divide both sides by 2. X equals 2. So I get the ordered pair, negative 1. All right, so now let's look at one that doesn't cancel as nice. So we have x plus 3y equals 7. 2x plus 2y equals 6. Okay, so nothing cancels here. So I have to make them cancel. So what we can do, we can multiply one or both of the equations by some number to make one of the variables cancel. Okay? The result, what we get then, is called an equivalent system because it still has the same solution. Okay? Even if I multiply something, an equation by a number, as long as I do it to everything, it's still going to be true. Okay? So I'm looking here. I think I want to cancel the x's. Okay, because I just need to multiply this by negative 2, and then it cancels. You could choose to do the y's, but notice 3 and 2, the least common multiple would be 6, so I would have to multiply both equations by something, which is perfectly allowed. But I want to do as little work as possible, so I'm going to get rid of the x's. So I'm going to take this entire equation and multiply it by negative 2. That'll give me a negative 2x to cancel with the positive 2x. Okay, so when I do this, I get negative 2x, distribute it to everything, so minus 6y equals negative 14. And I'm just going to copy this one down right again so I don't get confused on what I'm doing. And here's my new system. And look, now the x's cancel. So I'm going to go ahead and add straight up and down. Negative 2x plus 2x, those are gone. Negative 6y plus 2y gives me a negative 4y. Negative 14 plus 6 gives me a negative 8. Divide both sides by a negative 4. Y equals 2. Okay, now I have to solve for x, so I can use this equation, or this equation. It does not matter. I'm going to choose this one just because x has a coefficient of 1. So x plus 3y equals 7. X plus 3, instead of writing y, I'm going to plug in 2. So x plus 6 equals 7. Track that 6. X equals 1. So my solution is the ordered pair 1, 2. Okay, your turn. Please pause the video and try letter A. Okay, I want to get one of these variables to cancel. I'm looking at the x's just because this one's easy because it has a coefficient of 1. What cancels with 2x? Negative 2x. So I'm going to multiply the top by negative 2. Okay, when I do that, I get negative 2x minus 4y equals negative 8. And I'm not doing anything to the bottom equation, so I'm just going to write it. 2x minus 5y equals negative 1. Okay, I'm going to add straight up and down. Negative 2x plus 2x, those cancel. Negative 4y minus 5y is a negative 9y. Negative 8 minus 1 is a negative 9. Divide both sides by negative 9. Y equals 1. Okay, now you get to choose any of those equations. I'm going to choose the top original. So this is the one I'm going to use. X plus 2y equals 4. X plus 2, instead of writing y, I'm plugging in 1. X plus 2 equals 4. Subtract 2 from both sides. X equals 2. My ordered pair, 2, 1. Okay, pause the video, try letter B, please. Okay, letter B. When I look at this one, I could do either X or Y. Okay, it really doesn't matter. My eyes are drawn to the Y, however, though, because I have one positive and one negative. So this one just needs to be multiplied by 2 to cancel those Y's. Okay, so I would get 4x plus 2y equals 4. I'm going to rewrite the bottom one just right underneath it. Okay, and you might be doing this a different way than me, and that's perfectly allowed. Okay, there's not one right way to do this. Okay, so 4x plus x gives me 5x. 2y minus 2y is gone. 4 minus 5 is equal to a negative 1. Okay, divide both sides by 5. X equals negative 1/5. Okay, so now I need to solve for y. I'm going to choose the top equation. Doesn't matter, again, pick whatever one you want. 2x plus y equals 2. Instead of writing x, I'm going to write negative 1/5. Okay, 2 times negative 1/5 is negative 2/5. I'm going to add 2/5 to both sides. Y is equal to, let's see, this would be 10/5 to 12/5. Or you could write it as 2 and 2/5. Doesn't matter. So my ordered pair here is negative 1/5, 12/5. And there's the answer. Okay, so let's look at a word problem. A florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? Okay, please notice the picture. We have each regular bouquet has 5 roses and 11 peonies, and then each mini bouquet has 3 roses and 5 peonies. Okay, so we want to figure out what our variables are first. So notice the question says how many of each type of bouquet. So the types of bouquet are our variables because that's what we're trying to figure out. So I have a regular bouquet and a mini bouquet. So I'm going to call R for regular and M for mini. Okay, And we know we have roses and we have peonies. Okay? So let's start with the roses. Okay, so I know it's going to equal 118 because I have regular 118 roses. And the regular bouquet, how many roses does that need? Well, it needs 5. So I know I have 5 times the number of regular, plus how many does the mini take? Well, the mini takes 3. Hang on a second. Okay, and we have 3 for the mini. Excuse me. Okay, so now let's talk about the peonies. Well, I know I have 226 peonies. So how many peonies are in the regular? Well, we have 11. So 11 are. And how many are in the mini? We have 5. Okay, so here's my system. That's a really bad 3. Let me fix that. Okay, so I need to eliminate one of the variables. Okay, so this is really your choice here. I can either get rid of R's or the M's. I'm going to personally choose the M's because they're just smaller numbers to deal with in general. And I like smaller numbers if possible. Okay, so I'm looking at 3 and M. Or 3 and 5. What can I get 3 and 5 to cancel? Well, the least common multiple of 3 and 5 is 15. So I need to make them both look like 15. So 3 times what gives me 15? Well, it's 3 times 5. 5 times what gives me 15? 5 times 3. But be careful here. Okay, if I do this, they're both going to be positive and that won't cancel. So one of them needs to be negative. I'm going to choose the top one to be negative. Okay, so let's go ahead and multiply like crazy. Negative 5 times 5r is a negative 25r. Negative 5 times 3 is a negative 15m. And a negative 5 times 118 is equal to negative 590. Okay, now if I do the bottom, 3 times 11 is 33r. 3 times 5 is 15m. And 3 times 226 is equal to 678. From here, I can now do elimination. So let's add straight up and down. Negative 25 plus 33 gives me 8r. Negative 15 plus 15 cancels. Negative 590 plus 678 gives me 88. Divide both sides by 8. R equals 11. And that means I can make 11 regular bouquets. So now we got to figure out how many mini bouquets we can make. Well, you have choices. You can plug the 11 into the purple equation, the red equation, or either the 2 black equations. Does not matter. I'm going to go with the purple one just because it's on top and it's what I see first. So I have 5r plus 3m equals 118. So let's plug in r. So 5 times 11 plus 3m equals 118. 5 times 11 is 55. We need to subtract 55 from both sides. 3m equals 63. Divide both sides by 3. M equals 21. So we can make 11 regular bouquets, 21 mini bouquets. Okay, please try this problem. Okay, before the florist has a chance to finish the bouquets, a large order is placed. After the order, only 85 roses and 163 peonies remain. How many regular bouquets and mini bouquets can the florist make now? Okay, pause the video and try. Okay, so my variables are still the same. R is regular, M is mini. Okay, so start the roses. Well, we have 85. Okay, this one still takes 5, so 5R. This one still takes 3, so 3M. Okay, peonies, we have 163. Up here we know it takes 11, so 11 for the regular. And we know it takes 5 for the mini. Okay, again, your choice to eliminate whatever variable you want. I, again, am going to do the M's. So I multiply this one by a negative 5, this one by a positive 3. This gives me the equation negative 25R minus 15M is equal to negative 5 times 85, negative 425. And we get 33R plus 15M equals 163 times 3, 489. Okay, add straight up and down. AR, let's see, 4 minus 25, 64. Divide both sides by 8. R equals 8. So I can make 8 regular bouquets. Okay, again, it does not matter any equation you pick. I'm just going to take that top one. Instead of writing R, I'm going to plug in 8. 5 times 8 is 40. Subtract 40 from both sides. 3m equals 45. Divide both sides by 3. M equals 15. So in this scenario, we can make 8 regular bouquets and 15 mini bouquets. Okay, is this the last example? Yes, last example. We are going to choose which method is best. Okay, this one, I look at it, I see y equals stuff, and then I see another one in standard form. My immediate thought is to use substitution. Okay, so I pick whatever I want. I'm going to use substitution. Okay, this one is set up so nice for substitution. Okay, so let's go ahead and solve. 2x plus 7, but instead of writing y, I'm going to write what y equals. And that equals 10. To solve, we need to distribute. Let's see, 7 times 13 is 91. Get 9x. Subtract 91 on both sides. 9x equals negative 81. Divide both sides by 9. X equals negative 9. Okay, now I got to do y. So y is equal to x plus 13. Y equals, instead of writing x, I'm writing negative 9. Y equals 4. My ordered pair, negative 9, 4. And there's your answer. Okay, let's look at this one. 8x minus 2y equals negative 8. 5x minus 4y equals 17. Well, I don't have y equals on either, so I'm not doing graphing. Okay, I don't have x equals or y equals, so I'm not going to do substitution. So it looks like we're stuck with elimination. Okay, we need to get rid of either the x's or the y's. I'm going to do the y's because I can just multiply this one by 2 and I get 4. Okay, but however, I want to multiply by a negative 2. That way we have opposite signs. So this gives me negative 16x plus 4y equals 16. And I'm going to keep the bottom one exactly the same. And it's time to add straight up and down. Negative 16 plus 5 is a negative 11. 4y minus 4y cancels. 16 plus 17 is 33. Divide both sides by negative 11. X equals negative 3. Okay, pick whatever equation you want to solve for y. Really doesn't matter. I'm just going to pick the top one just because. 8x minus 2y is equal to negative 8. Okay, then instead of writing x, I'm going to plug in negative 3. Okay, 8 times negative 3 is a negative 24. Add 24 to both sides. Negative 2y is equal to a 16. Divide by negative 2. Y equals negative 8. So my ordered pair, negative 3, negative 8. Okay, last two, just kind of tell me what method you would choose. Okay, so letter A, I personally would do elimination just because notice they are lined up nice and neat. There's no y equals, there's no x equals. Letter B, I would do substitution because we have x equals stuff. And you just plug it in. If you want to, you can go ahead and solve those. This video has gone on long enough, so I'm going to go ahead and just keep moving on. Okay, so that's elimination. Say it's my favorite. Hopefully you guys liked it too. So here's your homework for tonight. You're on page 162. You're going to do problems 13 through 31 odd and 32. Please come prepared with any questions. Hope you guys have a nice day. See you later.